what I've done right here is I have a pentagon, 1, 2, 3, 4, 5 sides, and it's inscribed in the circle. Now, don't worry too much about circles. We're not really going to get in deep into the circles, but I just want you to see how this pentagon right here has a lot to do with circles. Okay, so watch what I'm going to do. I'm going to draw a line from the center. That's the center of the circle, or I could call it the center of the pentagon. By the way, it's not just a regular pentagon. I'm sorry. It's not just any old pentagon. It's a what? A regular pentagon, right. I almost misspoke. Alright. So that would be the radius, wouldn't it, of the circle? Alright, and so I don't think it has a special name, but this is just a line segment from the center of the pentagon to a vertex on the pentagon, okay? I don't think it has a special fancy name or anything, but that's what we'll do. I'll tell you what, let's make this a different color just so it stands out a little bit. How about that? That's ugly. Let's see. Nah, I don't like that color. It doesn't show up very well. Let's go orange. Oh, that's beautiful. Okay. So watch. What I'm going to do is go to this. Now look, what did I just form right there? A triangle. Okay, not just any old triangle. What kind of triangle? It's not necessarily regular. It's not necessarily. It's isosceles. Isosceles. Because look, what are the two orange lines? They're both the radius of the circle, aren't they? They're not parallel. Okay, they're both the radius of the circle, though, aren't they? All right, so they must have the same length. Okay, because all the radii of that circle are equal to each other. So this and this must be equal. So I've got an isosceles triangle right here. What if I continued to go from the center of this pentagon to each of the vertices? Somebody said it looks like the Chrysler symbol, and it does, doesn't it? Anybody have a Chrysler car? Chrysler's kind of out of business now, but anyway, that was the symbol for the Chrysler. It was a car company. Yeah, I knew he lived in Delaware. Yeah, he lived in Wilmington for a while, just a few years, a couple years, I think. Okay, here we go. Let's pay attention up here. Watch. So look what I've done. I've drawn, and what's true about how many triangles have I drawn right there? 1, 2, 3, 4, 5 of them, and they're all isosceles. Are they congruent to each other? Yes, they are all congruent to each other. Let me show you this. Are you listening? Because remember, it's a regular pentagon, isn't it? So on a regular pentagon, there's two things that must be true about a regular polygon. What's true? All the sides are equal and all the angles are equal to each other. Okay, so that means that all of these white sides right here are the same. All the orange sides are equal to each other. So look, side, side, side. All of these triangles are congruent to each other. Make sense? Okay. All right, that's pretty important to know. Also this, watch this. If I wanted to find this angle right there, and remember, all the triangles are congruent to each other. So that means this angle equals this one, this one, this one, this one. So all 5 of those angles are equal to each other. If I wanted to find the actual degree measure of this angle, Allie, what do you think? 360. Good. Take 360 and divide it by 5. Where'd you get 360 from? Because, yeah, if I went all the way around to there, that would be 360 degrees, wouldn't it? Okay, so it's 360 degrees all the way around, split evenly between 5 of them, right? So that's why I divide it by 5. Make sense? So I could find this angle right there. 72? All right. So that's 72 degrees. So I could find that angle right there if I wanted to. That's kind of easy to do. We call that the central angle of the circle. We also call this the central angle of the regular polygon. Make sense? All right. I'm not going to put the actual 72 here just yet because I want to come up with a formula for something. And I want it to be kind of generic, okay, very general. And I don't want to be specific to this particular regular polygon. All right, I want to be a little bit more general. What I'm trying to do is this, just so you know where I'm trying to head here. I'm trying to find a formula for the area of this whole pentagon, or any regular polygon inscribed in a circle, okay? Or any regular pentagon. I'm sorry, any regular polygon. So it could be 5 sides, 6 sides, 7 sides, 8 sides, 10, whatever, okay? I want to find a general formula, okay, for a regular polygon. I just picked a pentagon right here just because I did, okay? That's all. All right, so what we're going to do is this. I want to find a formula for the area of this whole entire regular polygon. Let's talk about the triangles. The triangles are important. I can find the area of a triangle. I know how to find the area of a triangle. And what's the formula for area of a triangle? Right. The area of a triangle is 1/2 the base times the height. So let's just take a look at this bottom triangle right here. All 5 are congruent, remember? If I take this, we'll call this B for base. And which one would be the height? Well, it would be from here. Perpendicular, right. Let's not say straight down. Okay, let's say perpendicular to this right here. That's very important. Okay, so that would be the height. We'll call that H for height. Now look what else. Look at the whole entire polygon. I went from the center of the polygon perpendicular.
Varsity boys lacrosse is now dismissed.
Perpendicular to one of the sides. I have a special name for this. All right, are you listening? This is probably a name that you've never heard before. So when I go from the center of a regular polygon perpendicular to one of the sides, look, I could have gone perpendicular to here, perpendicular here, here, or here, couldn't I? That length from the center perpendicular to one of the sides is called the apothem. That's a new word you probably hadn't heard before. Okay? Guys, check YouTube. Alright? Figure out what the lesson is. I'll put the lesson on there. You listen? Okay. Alright, so watch. So instead of calling it the height, let's call it A for apothem. You guys paying attention, right?
Yeah.
I don't think so. You still weren't paying attention. So instead of calling it H for height of the triangle, I'm going to call it A for apothem. Alright? So that's a new word. It goes from the center of the regular polygon perpendicular to one of the sides of that particular polygon. Everybody okay so far on that? Alright. How do I find the area? So instead of calling this H, what am I going to call this?
A.
Okay, A is 1/2 of, we'll call it AB. Alright? Is that alright? So that would be this one right here. Now that would be the area of this triangle. If I wanted to find the area of the whole entire polygon, that's right. You find out how many triangles that you actually have, right? Now there's 5 triangles and there's also 5 bases or 5 sides to your triangle, okay? Right? We'll call that N. N represents how many sides that you're going to have. They usually use N to represent the sides, okay? How many sides you actually have. Remember the 180 minus N? Do you remember that? Okay, all that kind of stuff. All right. So, so we're good so far. So right now, what's my formula? 1/2 ABN. Watch this. Instead of, I mean, what if I had like a 10-sided polygon, a decagon, a regular decagon, okay? Do I want to sit here and draw out 10 different triangles and all that kind of stuff? No, that would be kind of silly. Okay, what I could do is this. Now, what I want you to see is this. Look at the B times the N. That's why I put it like that. The B times the N. The B represents how long that side is, right? Okay, if I know how long this side is, and I know how many sides I have, for instance, this is 5, right? So let's say I knew the length of this was 7. I'm just making a number up. Let's say I knew the length of this was 7, and I knew I had 5 sides, and they're all equal. What did I just find? The perimeter of the whole entire thing, didn't I? Okay, so look, instead of calling this B times N, we could just say it's the what? It's the perimeter of that polygon. All right, so here's my formula. I'm ready to write out the formula. So the area of a regular polygon, it has to be regular, which means all the sides and all the angles are equal to each other. The area of a regular polygon is 1/2, what is it? A, which is the what? The apothem, okay, we'll call it the apothem, times the what? The perimeter, and there it is. Okay, so the area of a regular polygon is 1/2 AP, or 1/2 the apothem times the perimeter. Now the apothem was the new word for today. The apothem did what? It went from the center, where?
Bisected the triangle.
From where? What's the word? Perpendicular. That's how I want you to think of it. Okay? Yeah, it does bisect it, but that's not how we described it. It goes from here. Give me just a second, and I'll get you. Let's make this a little bit thicker. There we go. All right, so that bright yellow one right there, that thicker one, that's the apothem. Goes from the center, perpendicular to one of the sides. Doesn't have to be that bottom side, could be any of them. All right, but that's what the apothem is. Yes?
So it's kind of like the height.
It's kind of like the height of one of the triangles. Okay, it's the height of one of the triangles. You can think of it like that, but they use the word apothem for that. You got it?
Yeah.
Okay. So that was kind of nice. I mean, why did we do all that? We did all that just to show you where that came from. I could have just sat here and said, okay, the first thing we're going to learn is this is the apothem. How do you find the area? 1/2 times the apothem times the perimeter. Boom, you're done. But I think you got a little better appreciation, don't you, for where that comes from? We kind of figured it out on our own, didn't we? We already knew all this other stuff, and we just kind of came up with that on our own.
So why did we use this?
We just needed the circle because just to see the relationship between a regular polygon and the circle, because this is the radius, right, of the circle, and this is a radius of the circle, so that tells us that these two are equal to each other. It also is kind of nice too to find that angle. We didn't use that angle just yet, but we're going to in one of the problems. Okay, to find that angle, we know it's a central angle of the circle, right? So it's also the central angle of this polygon, regular polygon. All right, so there are definitely some relationships between the circle and the regular polygon. If you don't like the circle there, it's not really needed. I mean, you could have just done that, right, and it would be the same thing. Okay. All right, let's do an example actually of the kind of stuff they're going to have you do. All right, here's a big old regular hexagon, and this is the information that they give you in the book on this problem. This is an example right from the book. They draw this here and here. Matt, stop doing that. Please pay attention. They give you this, and they actually draw the apothem for you. So that's straight up and down. Perpendicular, right? Perpendicular to that side. I could have done that to any of these up here. They just decided to do it to this one to make things a little easier for you. They told you this whole length right here was 3. And that's it. That's all they told you. Tell you what, let's put some letters in here just so we can refer to some things. Yep, that's all they tell you. And what do they ask for? They say find the area of this regular hexagon. Regular hexagon. Alright, so they make sure that they do tell you it's a regular hexagon. So that's pretty important on this thing. So, do we have a formula to find the area of a regular polygon? Yeah, we just learned it, didn't we? Yep, it's 1/2 the apothem times the perimeter. Well, what's probably the easiest thing to find given this information right here? The perimeter, right, because you know one of the sides. So let's do that right now. That's right, it's 3 times what? 6, because there's 6 sides, and that gives you 18. So far, we have the perimeter. Now all we have to do is find the apothem, which is this right there. Let's change colors. Getting a little boring. What haven't we used? This purple? Is that too dark? Can you read that? Yeah, that looks nice. Okay, so we're trying to find the apothem. That's what we're trying to find. Well, I do know something, though. I know if I have an isosceles triangle, which I know that's isosceles, we discussed that earlier, and this is perpendicular, I do know that it splits this side right here into 2 equal parts. Okay? So, if this whole thing is 3, what is it from here to here?
1.5.
Yeah, it's 1.5 or 1.5, right? So I know, did I give this a letter? Call it D. So DC is 1.5. Is that still enough to find A? No. So I need something else. It's the only side that I know of this right triangle. What about an angle?
Since the apothem bisects the triangle, it's 30.
How do you know? Well, let's talk about this whole angle. Let's talk about ABC. Let's talk about the whole angle first. We talked about this a little earlier, didn't we?
Yeah, the central angle.
This is a central angle. So how many, if it's a hexagon, how many triangles would you have here if I extended all those out? 6. So this would be what? 360 divided by 6, which is 60 degrees. So this whole ABC is 60 degrees. But Matt, what were you saying?
Since it bisects, it cuts into two equal
That's
halves.
right. It bisects this angle up here also, this perpendicular line. When you have an isosceles triangle, okay, it bisects these and it bisects this segment down here. So if this whole thing is 60, then what's this one? That's 30 degrees. Good. If that's 30, then this is 60 degrees. Oh, that's kind of cool. We got a 30, 60, 90 triangle. Well, you could, I definitely wouldn't use law of sines, and I wouldn't use law of cosines. I could use a trig function, but I think what's easier is to,
Just do
yeah, because this is the short side, isn't it? They give you the short side. In order to find the long side, you just multiply it by the square root of 3. Isn't that a lot easier? It's a lot easier than going through the law of sines or law of cosines or even the trig functions. It's even easier than going through the trig
I don't
functions.
remember.
Well,
Wait, is that 3?
that's not my fault, okay? So this is the path of least resistance. This is easier. Listen,
It's easier just to multiply.
Yeah, that's what I do.
to do what? No, it's not.
That's the point that you...
Alyssa's, she's objecting to you. She's saying the opposite.
I said that all you have to do is times it by the...
That's right. It's 1.5 times the square root of 3.
Which is 2.6.
Okay, you don't even need that. Okay, all you have to do is use your calculator one time. If that's right, just times by 18. So look, the area, and then by half too, right? So it's 1/2 times the apothem, which is 18, times. I'm sorry, the 18 is perimeter. I'm sorry. Let's do that again. 1/2 times the apothem. It doesn't really matter what order you put it in, but I'm going to put it in this order, right? And look, you don't have to put 1.5 times the square root of 3 and put a decimal in for that. You can just keep it like this, put it in the calculator in one shot, times the perimeter. And what was the perimeter we said? It was 18. So look, you can just put this in your calculator and you're good to go. I think using that 30, 60, 90 in that particular situation makes things a lot easier. So let's put it in here. 0.5, okay, times 1.5 times square root of 3 times 18, and 23 point, let's say 4, okay, 23.4, and that's the area. I don't know what it's in. Let's say it's in inches and inches squared, okay, and that's how you find the area of that whole thing. What did we find? We didn't just find the triangle, did we? We found the area of the whole entire thing. What do you think? That's not so bad, is it? I really doubt that it gets much more difficult than what we just did right there, okay? Finding the apothem was the key. The perimeter was not that big of a deal, was it? That was pretty easy. If they told you the length of one of the sides, that was pretty simple. The apothem took a little bit of thought. You had to know what that angle was, that whole big angle. You had to know that it bisected, so that was 30. Then you had to be able to find, do some math and find what that apothem was. Plug it into your formula, multiply them all together, no big deal. Don't forget the 1/2, okay? A lot of guys on that kite and rhombus thing, some of you guys forgot to put the 1/2 in there. Remember that? It's 1/2 times the diameters, right? The product of the diameters, D1 times D2. So make sure you remember the 1/2. All right, let's go on to something a little different. All right, here's my crazy looking figure right here. So I'm finding the area of this whole entire thing. So I want to find the area of this semicircle. So the semicircle is pi r squared divided by 2. That's a weird looking 2. Try that again. Okay. So it's pi r squared divided by 2. So let's put the numbers in. So it's pi radius, which is 4, squared divided by 2. Let's simplify that a little bit so we can work with it. That's 16 divided by 2, which is 8, or just 8 pi. So the area of this semicircle is 8 pi. That's not the whole thing, though, is it? Let's see how else we could break this down. I guess there's a couple ways we could do this. Probably, the nicest way is probably to take this and just go straight up to here. Don't you think? So now what I have? I got a rectangle and I have a triangle. Let's do the rectangle. The rectangle is actually really easy. So the area of the rectangle is 7 times 4, which is 28. Okay, so far we have 8 pi and we have 28. Don't take the 8 pi and put it in as a decimal right now. We'll just put it all into the calculator once we're done. Okay. What about this thing right here? We have to find the area of this triangle. Well, it's 1/2 the base times the height, isn't it? Well, I know the base. What would the base be considered right here? 5.7? 5.7 is the hypotenuse. Remember, the base and height have to be perpendicular to each other. So this would be the base. From here to here would be the height, wouldn't it? From
You
here
have to find the
to here. So that would be the height. So right, I have to find the height. So I'll do Pythagorean theorem.
Base can never be the hypotenuse?
No, not unless you have a line that's perpendicular to it. That's the height. It could be the base, but look, then that would have to be the height. You follow me? And that's going to be a lot harder to find than this is.
And that's still not the hypotenuse.
Okay.
It's just the base.
Well, it would be the hypotenuse of this triangle. Sure it would. So it could be the base, but the hypotenuse or the height has to be drawn perpendicular to the hypotenuse. Okay, and that would be really difficult to find. All right, so let's do this. So what do you go? H squared plus 4 squared equals 5.7 squared. Alyssa, what'd you get when you solve for H? 4.1? Okay. So the area of this triangle is 4.1. Now, what do we do with all three of these when we're done? Find the total area.
What? It's not 4.
You just said it was 4.1.
No, the height of that was 4.1.
Oh.
I didn't plug it in.
Oh, we didn't plug it in. You're just telling me the height. I'm
Yeah.
sorry.
It's not
Okay. Yeah. That was my fault. Oops. That was my bad. Okay, so the height is 4.1, right? And so we have to find the area of the triangle. So the area of, I'll call it T for triangle, is base times height. So it's 4 times 4.1 divided by 2, right? We can do this. 2 goes into 4 what? Twice. 2 times that is 8.2, right? So there we go. Now we'll put this, 8.2. So that is the area of the triangle. Now, what do we do to find the total area? We'll call it area total. Yeah, just add them all up. Take 8 pi plus the 8.2 plus the 28, and hopefully you'll get somewhere around 61.3. Is that right? Okay. It's in feet, so we'll call it feet squared. There'll be a few, yeah. Now, there's another type of problem. We're kind of running out of time right here, and I ran out of time in my other class as well. That's why I couldn't answer questions on that homework last night. But there are some problems where this is by addition, right? You split them up. Yes? This one right here? Because I did Pythagorean theorem right here. Okay, and then I got 4.1 when I did Pythagorean theorem. Were you thinking 3, 4, 5? Were you thinking 3, 4, 5 triangle? Yeah, because it's 5.7. It's not just a 5. Okay? Good try, though. Okay, what was I saying? Oh, on this, what did we do? We added up, didn't we? See, we added. We found the semicircle plus the triangle plus the rectangle. There are situations where you're going to have a picture where you don't find the area by adding. It's easier to find the area by, what do you think? Subtracting, right. So I just don't have time to really draw it out for you, but I'll just kind of sketch it. I like to use the straight line thingies, but watch. Boom, boom. And let's say this was the shaded part right here, okay? And you wanted to find the area of that. So watch what you're going to do. Depending on the information that they give you, instead of trying to break this down and add them together, the easiest thing probably, yeah, would be to find the area of that whole entire rectangle and then do what? That's right, take away that triangle from it. So it's probably easier, if that's a right angle, depending on the information they give you, it's probably easier to find the rectangle, take away the triangle from it, and then you've got everything that's left. Okay, that's what finding the area by subtraction would be. Does this make any sense? So it just all depends on what they give you and what the figure looks like if you want to add them all up like this, or if you want to find the whole thing, subtract this from it, and then you got what's left over. Okay? Alright. Let's do some problems. This is section 11.5, 4, sorry. 11.4. And we're going to do numbers 10 to 24. Oh, you want
796 and
pages?
797.
Yes. 796 and 797. Alright, so there's your homework. Enjoy that.